Okay. So tonight at 9 p.m. is due material from section P6, as is the web assigned from P6 and P7, or P5 and P6, sorry. And I will like activate a another web assignment. This one is due Tuesday, huh? We can make this one due a little later. 7 and 8. Since this is due Thursday, let's make this due Thursday. So that's the 27th. All right, and then I'll activate the next web assignment coming up for sections 1.1 and 1.2. And exam 1 is going to cover sections P8 to P2 to P8. 1.1 to 1.4 will be on Wednesday. Okay, Wednesday, June 2nd. So that's Wednesday next week. All right, so for sure, that's the date. Okay, so last time we went over problems in section P7. These rational functions, or rational expressions. And basically we're just kind of like simplifying these things. Maybe we can do a couple more. So let's take number 65 was assigned, 98, 59. Let's look at 59. So some more problems in P7. So 59, simplify the rational expression. And again, what that means is to express as a rational expression and factored with numerator and denominator factored, or factored completely, or in standard form with no common factors on the top and bottom. So here in these groups of problems here in P7, so now we're going to look at what I like to call nested fractions. So here you've got fractions within fractions. Okay, so here's the rational expression, but it's got fractions within fractions, and that, typically you don't want to leave it in that form. You want to resolve the nested fractions into just one fraction with the numerator and denominator that are both rational expressions and factored or standard form. Standard form being a sum of monomials, right? So here, now what we want to do is the following. The basic way of simplifying a nested fraction, a over b, over c over d, okay, you take the fraction on the top and you multiply by the reciprocal of the fraction on the bottom. Can I apply that here yet, though? Can I apply this here yet to this? The answer is no, and why? Why is that the case? Why is that the case? Why can't I take, a fraction
They're
a over
both
b?
part of addition and subtraction.
Right. Essentially, we don't have a fraction on the top and a fraction on the bottom. We've got a sum of some things on the top, one of which is a fraction, but it is not just a fraction on the top. Right? So, in order to get just a fraction on the top and just a fraction on the bottom, I have to resolve this addition first. So, how do we resolve the addition? Of course, you need, for adding fractions, a common denominator. So, what would I change 1 into to give me a common denominator with the 1 over x?
One over x.
Well, 1 over x is not equal to 1, right? But what is equal to 1 with x on the bottom?
X over x.
X over x, exactly. Right? Plus 1 over x. Here, 1 over x. Now, what do I got to do with this one here, the minus 2? Right? I'm going to multiply minus 2, again, by 1. But I'm going to write 1 as what? Like what you just said.
2 over x.
Well, again, 2 over x is not equal to 1. What is equal to 1?
X over x.
X over x, again, yeah. So, I mean, here 1 is just x over x. Here, it's 2 times 1. So, 2 times x over x. All right, so on the top, I can just go like that. X plus 1 over x. On the bottom, I got a little bit of work to do. 1 over x minus, now this becomes, when you have this coefficient out front, the fraction, you multiply it by the numerator, right? 2x over x. So this becomes x plus 1 over x over 1 minus 2x over x. Now I've got a fraction on the top, a fraction on the bottom. So I can multiply the fraction on the top by the reciprocal of the fraction on the bottom. So now we can apply that. What did I do? 1 minus 2x. Now I can apply this bit here. Okay. Cancellation. What cancellations do I have? You can take it another step. You can write it like this. X times x plus 1 over x times 1 minus 2x, right? Common factor of x on the top and the bottom, and that goes away. And there we go. And this, now at this point, you could have maybe some common factors on the top and the bottom, so you have to factor the top and factor the bottom, cancel out more common factors if it wasn't already factored completely over here, but not the case with this one because the polynomial has degree 1, so it's not going to factor anymore. Okay, so there's a lot involved in that bit of algebra that we just did, right? This simplifying nested fractions. Okay, now I assigned for you to hand in for piece 7, 64. Okay, 64 is, let's do 63. So 63 is very similar to 64. It's not one of the ones assigned, but we'll do it as a template for you. So here's 63, right, very similar to 64. So same thing, simplify the nested fraction. Over x plus 3. All right. So, I can't apply this thing here because I don't have a fraction on the top and a fraction on the bottom just yet. I will. All right, so I can't apply this just yet. I need to resolve the additions, right? I mean, I have a sum of two fractions. Well, a sum of two fractions is a fraction, okay, but not just before you've actually done the sum or the subtraction. In this case, so we need a common factor for these two fractions on the top and bottom in order to add them first. Right, what factors do you see on the bottom of these two fractions here? And this down here is just gonna be like that, and that's gonna sit there for a little while. We're not gonna be able to do anything with it yet. Right, I've got a factor of x minus 4 and a factor of x plus 1. So a common denominator would be x minus 4 times x plus 1. Right, so what can I do to get that factor, that missing factor of x plus 1 on the bottom of this fraction? What should I multiply it by? Well, again, I always multiply by 1 times 1. But how am I going to write the 1 in order to get that missing factor of x plus 1 on the bottom? What do I multiply here? Same thing on the top
X
and
plus
bottom.
1 over X plus 1.
Right. And then this one is going to get multiplied by what? To get this x minus 4 factor on the bottom.
X minus 4 over X minus 4.
Good. So we've got x minus 3, x plus 1 over x plus 1, x minus 4 minus x plus 2, x minus 4 over x plus 1, x minus 4. All of that junk over what was on the bottom before. Now remember, like on the bottom of this fraction here, I mean, this is not a fraction. Well, it is. It whenever you have just a expression that really isn't a fraction, you can always make it a fraction just by putting it over 1. All right, so that's what we need to do here to eventually apply this thing. Right, so far we're here. Right, so now I've got a common denominator with those two fractions, so I can actually subtract them. So x minus 3 times x plus 1 minus x plus 2 times x minus 4 over x plus 1 times x minus 4 over x plus 3 over 1. Alright, now before I apply this, fraction simplification here, nested fraction simplification, first I wanna put it in standard form and refactor this up here. Okay, there's bound to be some common factors, but in order to find those common factors, I'm going to have to factor the top here. But before I can even do that, I've got to put it back in standard form because there's no common factor here and here, so there's nothing I can do really other than to just put it back in standard form. So this one, when I multiply this one out, when I use that FOIL mnemonic, it becomes, so x squared minus 2x minus 3. I'm going a little faster here. X squared minus 2x, so minus 8 over x plus 1, x minus 4 over x plus 3 over 1. Now let's do the simplification here. Minus 3x plus x is minus 2x plus 2x minus 4. Yes. That's surprising. So here on the top, x squared minus x squared, 0. Minus 2x minus 2x. So that's 0. Right? So this and this cancel additively. This and this cancel additively. And here we have minus 3 minus 8. So it's minus 3 plus 8. So it just becomes 5 over x plus 1, x minus 4, over x plus 3 over 1. All right, so now I'm going to take this fraction on the top, multiply it by the reciprocal on the bottom. No common factors. And we have the numerators and denominators in factored, numerator and denominator in factored form. A lot of steps in doing those, okay? But, you know, those are the things you have to go through to get to the final simplified form. It's all steps that we've covered, but still multiple steps. And the importance of writing is now in how you write your expressions and how you use, you know, equals and how you work across the paper. I mean, it's starting to become more important because this is a rather lengthy calculation, and some of you are great at it, by the way. Some of you really write your mathematics very clearly, and that's a reflection of a clear understanding. But others, it's not so much. The writing is not so much clear. All right, and not that you don't necessarily understand it, but you will get lost in the calculations that require multiple steps as they get more complicated. It's just, inevitable, unfortunately. So, take some care to write things properly. So here I'm starting with this expression is equal to this expression via various techniques we've talked about it, and at the end it's equal to this expression. It's not an equation, it's an evaluation of an expression, or a simplification of an expression, using a string of equalities. All right. So that's 63, and 64 I asked you to hand in, really similar to that, okay? Oops, did I do 64 instead of 63? I did, didn't I? Wow. Shoot. That was 64. Alright, well. Well, there's nothing I can do about that now. And then 65 was also assigned, but I think that's perhaps enough for now. Okay. Oh, so P8, we covered that last time. Let's do some problems in P8. So P8, 12 to 63, every third problem. So number 15. So finally, after everything that we've done in chapter P, we as I was saying, we never had an equation to solve. So finally in P8, they give us an equation and they ask us to solve. So the simplest linear equation looks like this. All right, and again, what's an equation? An equation has got a left-hand expression, right-hand expression, and an equal sign in between. And what you want to do with an equation usually is solve for whatever unknown quantity or quantities you might have in the equation. Here it's x. Right? And this one, I mean, I'm sure you've seen it before. What we want to do is move the constant over to the 6 over to the other side. So we add 6 to each side of the equation. We have 15x is 20. So then I want to divide both sides by 15. Right, the 15s here go away. And I'm left with x equals 20 over 15. 20 over 15 is 4/3 in lowest terms. Right, so that's the really the very simplest type of equation that linear equation that you can solve, and you always get an answer, and that answer is always unique. 18, same thing. 21, right? It's an equation in which both sides are polynomials of degree 1. Polynomial of degree 1 is also called a linear polynomial. So what you want to do is push all the numbers to the right, push all the x's to the left, or the other way around, and then combine like terms and then divide. Right, so I want to push the 3 over here, so I'm going to add 3 to both sides, and we just get 0 on both sides, and then I want to move the x's, the 5x on the left over to the right, so I subtract it, and then I want to divide by 8 to isolate the x, divide by -8. So the -8's cancel, and I'm left with x is equal to, and then 0 over -8 is what? What's 0 when you divide it 8 ways?
0.
0. Zero, you hope. Yes, your hopes are correct. 0, when you take nothing and you divide it evenly 8 ways, or you divide it evenly 10 ways, or you divide it evenly 3/5 ways, or whatever. When you take nothing and you divide it evenly, you get nothing for each part. The thing about 0 and division is you can't divide by 0, right? So 0 over anything is 0. Anything over 0, right, is undefined. Right? I mean, why is 12 over 4 equal to 3? Well, division is the reverse operation. Is the reverse operation of multiplication, right? 12 over 4 is equal to 3 because, right, 12 is equal to 3 times 4. Right? You're reversing the multiplication, right? So instead of multiplying 3 by 4 to get 12, you take 12 and you divide it 4 ways to get 3. Fine. 0 over anything is 0 because 0 times anything is 0. 0 times anything is 0. However, anything 0 times, I mean, if you were to say like 17 over 0 is x or something like that, well, 17 is not equal to x times 0. X times 0 is 0. And so it'll never make sense as a reverse for multiplication. dividing by 0, because whatever times 0 is always 0. So the only time, like, there might be something to say is when you have 0 over 0, but we're not going to deal with that. Okay, so you can divide 0, you can divide nothing evenly. Each part is nothing. But you can't divide into nothing. So that was 21, 20, so every third problem, 24, similar to 21. Let's do it. So 24, 1 minus x equals x plus 4. All right, let's push the constants to the left. We'll subtract 1 from each side. So minus x is x plus 3. Now push the x's to the left. So subtract x from each side. So minus 2x is equal to 3. Divide by minus 2. All right, so x is equal to minus 3 halves. So 3 over minus 2 and minus 3 halves are the same thing. Okay, it's just the negative of the fraction 3 halves. So very simple equations, linear equations. 24, 27, similar to that, except, we've got some fractions to deal with. So all right, so let's add 1 to each side of the equation. Now, when solving equations, right, the quantity that you change the left-hand expression by, you must change the right-hand expression by. That's why we have to add 1 to both sides, right? Because the left-hand expression is equal to the right-hand expression. So if I'm going to add 1 to the left-hand expression and expect it to still be equal to the right-hand expression, I have to add 1 to the right as well. What you add to one side, you must add to the other side. What you multiply one side by, you must multiply the other side by. Okay? The only time you can do something to one side and not the other is if you add 0 to one side, because adding 0 doesn't change it, nor does multiplying by 1. Anyway, but we'll have some tricks like that later. So this is 5/3 x plus 7. By the way, let's write these consistently. So this is 5/3 x. This is x over 3. Remember, x over 3 is also 1/3 x. Right? So they kind of mix the two ways of writing it in this. It's nice to write them both the same way. Either write x over 3 and 5x over 3, or write 1/3 x and 5/3 x. Write them the same way, so we're consistent. So I want to move this x's over here, so I'm going to subtract 5/3 x from both sides. So I got
Isn't it
1/3.
plus 8 now?
I'm sorry?
Isn't it plus 8 now?
Oh, yes, plus 8. So I got 1/3 x minus 5/3 x equals 8. 1/3 x minus 5/3 x is what? Third minus 5/3 is?
Negative 4/3.
Yeah, negative 4/3. Treat them just like, you would integers, right? I mean, you just add. All right, so now, I mean, I could divide both sides by negative 4/3, but that kind of like introduces some extra steps into it. So what I'm going to do instead is multiply both sides by the reciprocal, which is the same as dividing. But it's a little bit of a cleaner expression. So minus 3/4 times 4/3 And minus 3/4 times 8. See that? Minus 3/4 times minus 4/3 is just 1. Right? Because the 3's and the 4's are going to cancel. So that's just 1. Yeah, remember that. A over B times B over A is just 1. So this is X. And then here, the 4 and the 8 cancel, leave 2, gives me minus 6. By the way, you can check your answer at the end. Whenever you solve an equation, you can check your answer. Check your answer to make sure it's correct. Okay? Take that minus 6, plug it into the original equation. So the original equation was x over 3 minus 1 equals 5/3 x plus 7. Right? Plug in x equal to minus 6. Okay, so minus 6 over 3 minus 1 is equal to 5/3 minus 6 plus 7. Minus 6 over 3 is minus 2. Minus 6 and the 3 cancel, leave a minus 2. So this is minus 10 plus 7. Minus 2 minus 1 is minus 3. Minus 10 plus 7 is minus 3. Right? Checks out. If your answer wasn't correct, you would get something. You get like minus 3 is equal to 7 or something like that. Right? I mean, you'd get something, something that would indicate you had an incorrect answer. Well, there's two things that could happen. If you got something here that doesn't make sense, 1 is equal to 0 or 3 is equal to minus 3 or something contradictory. Either you made a mistake in your check or this is incorrect. One or the other. But if you get the same answer, if you get this answer and then that's correct, you can have confidence that, that you got it right. Okay, so you can always check your answer when solving equations. So that's a good example and a good practice to get into. I always hear hear people say, "Oh, I made so many little mistakes, on the exam. I made so many little mistakes, and it added up to so much off, or whatever the case is." I'm always a little kind of surprised when I hear people say that and kind of lament it. Anyone ever heard the saying, "Measure twice, cut once"? Come on now, I'm sure you have. Measure twice, cut once. Right? You're killing me, guys. You never heard that?
Yes.
Yes, of course. Works with your hands. I mean, my dad was a tailor, and he said measure twice, cut once to me several times. Okay, so with garments, and then of course people that build things, carpenters, measure twice, cut once. You do a problem and then you check. Do the problem, check your answer. Do the problem twice, check your answer. Cross your I's, dot your T's, or cross your T's, dot your I's. Check and recheck, and that's the way to avoid little mistakes like that. Well, to try to avoid little mistakes like that. Sometimes it happens. Right? I mean, you're conscientious about the way you do one thing. When you're conscientious about the way you do your math, it's the same. It's the same outcome. You avoid those little mistakes. Measure twice, cut once. All right. So up to, let's do a couple more. 63. So 36 is a good one. Let's take a look at that. So now it's getting a little more complicated. So we have 3x minus 5x over 2 equals x plus 1 over 3 minus 1/6. Solve for x. So we have coefficients for x, but they're all like fraction coefficients. And that's fine. We can work with that. Okay, so now since the fractions have become more complicated, let's work just with fractions rather than fraction coefficients. So what I mean by that is I want to add these two x's here. Right? I have 3x and 5x over 2. But I can't add these two fractions without first getting the common denominator. Right? So I'm going to multiply 3x by 2 over 2. And this one's already got a common denominator of 2. This one, these two, I need a common denominator of 6. So I'm going to multiply x plus 1 over 3 by 2 over 2. Oh, let's do it a different way. Let's do it a different way. I think this will be easier. A common denominator for all these fractions that are shown here would be 6. For all these fractions shown here, a common denominator would be 6, a lowest common denominator. So what I'm going to do is I'm going to take both sides of this equation and multiply by 6. Now, when you multiply both sides of an equation by a number or some other quantity, if you still have your addition operations going on or subtraction operations going on each side of that equation, you have to put parentheses around the entire left-hand expression and parentheses around the entire right-hand expression. So now let's multiply through by 6. This becomes 18x. This one, okay, 6 times 5x over 2. The 6 and the 2 cancel, leave it 3. This one, 6 times x plus 1 over 3. The 3 and the 6 cancel, leave it 2. And then 6 times 1/6 is just 1. All right, so I've got 18x. 3 times 5 is 15, minus 15x. 2 times x plus 1 minus 1. So I still need to, now all those fractions are gone. Right? I took what was a lowest common denominator for all of these fractions here, which would be 6 in this case. And I multiply both sides of that equation by that common denominator, and then all the fractions go away after I multiply it through. So now I can simplify this expression, get all the x's to the left, all the numbers to the right. That's going to require a couple steps here. So 18x minus 15x is 3x. Multiply through here, 2x plus 2 minus 1. So notice I'm stacking my equations here. Right? When you solve equations, you stack the equations. You don't work in a string of equalities. You stack an equation, left-hand side, right-hand side, with the equal in the middle. Next equation, left-hand side, right-hand side, with the equal in the middle, usually with these guys lined up if you can possibly do it that way. Okay, if you got enough space. That's the proper way to write equations when you're solving, is to stack them like this. Okay, so and then of course you're going to have to come back to the top here. So I got 3x equals, so this is 2x plus 1. Now I've got it back down to 3x minus 2x. This is just x, and then this is 0, and that's just 1. So no division necessary, I just got x equal to 1. Okay, let's check. Let's check. take your original equation, and then I'm going to plug in x equal to 1 into the original equation. So this is going to be 3. This is going to be 5/2. This is going to be 2/3. That's minus 1. All right, 3 is 6/2 minus 5/2. This is 2/3 minus 1. 2/3, and then 1 is 3/3. So 6/2 minus 5/2 is 1/2. Something's wrong here. And this is 2/3 minus 3/3. Something went wrong. Right? Because here I'm going to get minus 1/3. At 1/2 is not equal to minus 1/3. So there's a mistake in here somewhere. Let's take a look. 6 times 3, 18. 3 times 5 is 15. 2x plus 2, and that's 1. 3x plus 1, x equals 1. 3, 5/2, 2/3, 1. Six halves minus 5/2 is 1/2. 2/3 minus 3/3 is 1. Where is the error?
It's supposed to be negative 1/6 instead of negative 1.
Oh, that's a 1/6. Yeah. No, 1. 6 times 1/6 is 1, 1, 1. Oh, this is a negative. Right? See what I did? No, that's still right. That's still right. Still plus 1. Which is negative 1/6? I'm sorry.
The original equation had negative 1/6.
Yeah, right here.
Yeah. So wouldn't you have to put the negative 1/6 on the other equation over here?
Right.
On the right
Oh,
side?
yeah. There we go.
Yeah.
So we messed up the check. I messed up the check, not you guys. Right. The original equation has a minus 1/6 here, minus 1/6. So 2/3 minus 1/6. So that's 4/6 minus 1/6. So this is 1/6, and no, this is 1/2. 4/6 minus 1/6 is 3/6, which is 1/2, of course, right? So we'll just leave it at that. Right, so we have to get an equality in our check. If you don't, it means there was a mistake in the check or in the original solution. So, and when you check, you have to check with the original equation. And what I did is instead of putting the 1/6 here, I put a negative 1. So of course that threw the answer off. Alrighty, let's see. Up to 63. So that was 36. How's about, now what did I assign to hand in? So piece, no, 28 and 46. So 46. 46, let's do 48. Or let's do yeah, 40, well, as a warm up to 46, let's look at 45. So this is like 46. So I have 2 over t plus 6. So instead of x, they're using t in this one, which is fine. 3 over t minus 1. So solve for t. All right, so I've got 2 fractions. Now, when you have a fraction equal to a fraction, you may remember this thing called cross multiply or something like that. So cross multiply is just a more specific form of multiplying by a common denominator, essentially. Okay, so here I've got fraction t plus 6 over t minus 1. Or sorry, a fraction over t plus 6 and a fraction over t minus 1. A common denominator would be the product of those two. So on each side, those numerator and denominator common factors, they cancel, and I'm left with 2t minus 1 times 3t plus 6. So, right, you may remember that as cross multiply. But that only works in, just the situation where you have a fraction equal to a fraction. So if you have a fraction equal to a fraction and you want to solve, you can cross multiply. 2 times t minus 1 is equal to 3 times t plus 6. But that's a specific instance of multiplying both sides by a common denominator for all fractions in the equation. Okay, so I'm actually not asking you to do that in any of the problems. Multiply across the equation by a common denominator. We'll have some of that later, maybe. We'll see. But just so you've seen it, we're doing it here. So this one multiply through by 2. This one multiply through by 3. So subtract 3t from each side. So minus t minus 1 is 18. Add 1 to both sides. So minus t is equal to 19. And then divide by -1 or multiply by -1 or just negate both sides or something like that. So minus t is 19, so t is negative 19. Okay, and we can check that. T is negative 19. Negative 19, negative 19 plus 6. So plugging in t equal to negative 19. So negative 19 plus 6 is negative 13. Is equal to 3 over negative 19, negative 1. What happened here? I'm on a roll. I'm doing so poorly here. 2t minus 2. So that's minus 2. So then I have to add 2. So negative t is 20. 20. So negative 20 plus 6 is negative 14. Negative 20 minus 1 is negative 21. Put these fractions in lowest terms. That's 1/7. This is 1/7. Negative 1/7. Right? So that checks out. So it's a good thing I'm checking these because you can see, small mistakes will get you. Right? And, really the only way to avoid them is to do the solution once, check it, do the solution again, do this kind of check to make sure the solution works, and then check again. So measure twice, cut once. It applies everywhere. Tailoring, carpentry, and math. So that is like number 46. And then, there are the ones that are a little more complicated than that. So 48. And that'll be enough for this section, I think. 12x minus 5 over 6x plus 3 is equal to 2 minus 5 over x. So let's factor before we get into this too much. Okay, so a common denominator for all of the fractions across the whole equation would be 3 times 2x plus 1 times x. 3x, 2x plus 1. This fraction has a factor of 3 and a factor of 2x plus 1. This one has a factor of x. So combining all those different factors into one product will give me a common denominator for all the fractions present in this equation on the left hand and the right hand. So I'm going to multiply both sides by 3x, 2x plus 1 over 12x minus 5. Here on the left, the 3 and the 2x plus 1 cancel, and I'm left with x times 12x minus 5. Here, before I can do any canceling, I have to multiply this common denominator, this product, through both terms. So 2 times 3x times 2x plus 1 is 6x times 2x plus 1. Minus 5 over x times 3x, 2x plus 1. X's cancel here. Multiply through 12x squared minus 5x. Multiply through here, and this is 12x squared plus 6x minus, now I need to clean up this expression before I can multiply through. Keep working on the right-hand side here. The left-hand side is done. 12x squared minus 5x. Right-hand side, 12x squared plus 6x minus 30x minus 15. 12x squared minus 5x, 12x squared minus 24x, so minus 30 plus 6, minus 15. Don't like those x squareds, but they go away. I subtract 12x squared from each side, and it went away. Add 24x to each side, and I get 19x is equal to minus 15. I don't think that's right. $12x minus 5. So x times 12x minus 5. 6x, 2x plus 1. So that's 15 times 2x plus 1. 12x squared plus 6x. 30x minus 15.
I thought you couldn't distribute across like terms that are in parentheses that are addition and subtraction.
Yes, you absolutely can. That's just distributing this over this term and that term.
Okay.
So 2 times this is 6x times 2x plus 1 minus 5 over x times 3x, 2x plus 1. The x's cancel. 5 times 3 is 15. So 30x minus 15. So that's 24x. See, the problem is I'm getting this ugly fraction, and I sort of don't think it should be correct. But we can check. I don't believe it. I don't believe it. 12x minus 5. So 12x squared minus 5x. 2 minus 5 over x. 6x, 2x plus 1. 12x squared plus 6x. 15x times 2x plus 1. 30x minus 15. 30 minus 6 is 24. Add 24 minus 5 is 19. And, well, let's check. So 12 times minus 15 over 19 minus 5. So see, this is why I don't want to check, is because I don't think that's right. That it's going to throw that nasty a fraction at you. So what number was this? 48. No, that's right. Yeah, that's right. I'm not going to go through the check because that's just too much like arithmetic, but it's actually correct. Normally, like in a text, they don't throw like really nasty fractions at you like that. Because it's hard to check the answer, because you just end up dealing with fractions a lot, which is not a good use of time. But this is actually correct. So not a well-designed problem. All right, so I'm not asking you anything like this one on the exam or in the homework, but I mean, at least you've seen this technique of multiplying through by a common denominator. We've done a few examples of that. Okay, well, that is all for today, 10:54. So tomorrow we'll get straight into 1.1. Don't forget tonight, okay, P6 is due, as is WebAssign for P5, P6. And the first exam, Wednesday, June 2nd. Okay, now, remember, these PDF notes are always going to be listed on the course website. So whenever you need this information, you just go straight there, okay? All right, everybody, so have a good day. Email me with questions or concerns, or if you want to meet, and I'll see you tomorrow.